Use algebra to solve. It is a cos squared. So because it's a cos squared, it's quadratic. How do you solve quadratic equations? You make one side equal to 0. So I'll move everything over to the left-hand side. And then you either have to factor or use the quadratic formula. I personally like factoring whenever you can. Some people don't because they're not good at factoring. Okay? This one you can't factor. No. You want to try to fight? You can check them all. It doesn't actually factor. So now, what do you have to do? You have to use your quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c over 2a. This is the telltale whether you can factor or not. If whatever you get inside your square root is a perfect square, like if we got square root of 16 or square root of 25, that tells you you could have factored it. But since it's the square root of 13, it means we were right. It was not factorable. From here, we would have two possibilities. We either have cos x equals negative 1 minus the square root of 13 over 6, or cos x equals negative 1 plus the square root of 13 over 6. Yeah, you can. They have the column continue on the next page for you for this one. This might be a good one to actually estimate these with a decimal. So I'm going to go to my calculator. Use my fraction button. That's not my fraction button. Okay, negative 1 minus the square root of 13 all over 6. Negative 0.767. Okay, what can I do with this? Well, I can find my reference angle. How do I find a reference angle? By doing cos inverse of the positive value. So a couple things. That value is negative right now. If I times that value by a negative 1, that makes it positive. And now I can do cos inverse of that answer. That's the positive value. And I find my reference angle is 39.9. Is this question in radians or degrees? Radians. Ugh. So go to your mode button, change it back to radians. And we do cos inverse of this answer, 0.695. Are you getting better at these reference angle questions? Because this will be on your test, reference angles and stuff, right? This is just review. So I'm going to store that as x. That's my reference angle. When is cos negative? Quadrants 2 and 3. Pi plus my reference angle in quadrant 2, or that's quadrant 3. Pi minus my reference angle for quadrant 2, 2.45 and 3.84. I'm going to just make a little note to myself, because of something bad that's going to happen later, that that was quadrant 2 and quadrant 3. Yes?
So wait, we did 2 and 3 because, like, up there was negative?
Cos is negative right here. Technically, this whole thing is negative. Now I'm going to go to the other one. I'm going to cheat a little bit. like cheating. There we go. I'm going to retype this and just change this to a plus sign. Was that quicker? I'm not sure. But I get 0.434. Cos inverse of that answer to find my reference angle, 1.12. And I'm going to store that as x. Because cos is positively in quadrant 1, I need to find the one in quadrant 4. So 2 pi minus my reference angle will be quadrant 4. So x equals 1.12 in quadrant 1 and 5.16 in quadrant 4. But what was our actual domain? See, by now, with a question like this, can you see how you would have forgot what your original domain was? You're just sort of, it's so intense that by the time you solve it, you're like, whew, I just want to keep going. I just want to turn the page of this because there's a big question on your exam. But you might get it wrong because the domain was different. So here, yeah, you would still get some marks. It says between negative pi and pi. So that means it's usually 1 mark. Okay? If you did it in degrees and it asked in radians, you lose a mark. Okay? We're trying to find between 0 and pi and 0 and negative pi. So what does that mean? That means this one is out and this one will be out. Does that make sense? So our final answer should be x equals 2.45, and quadrant 3 with the same reference angle negative will be negative 2.45. And here 1.12 will stay, and quadrant 4 will have the same reference angle as quadrant 1, negative 1.12. Yes?
I know you've explained it like 50 times, but I don't get why they're out. Like, I don't know why.
So the domain was given to us to be this, which only goes up to pi. So it includes quadrant 1 and quadrant 2, but it doesn't include quadrant 3 and 4 for positive answers because it stops at pi. But it does include quadrant 4 and quadrant 3 in the negative direction because it starts at negative pi. Does that make sense? All right. And then what's your general solution for part B? And again, for your general solution, it doesn't matter which coterminal angles you use. I like to use my positive ones in the first time around. So I will reuse the 5.16 and the 3.84. It's in radians, so we go plus 2k pi for each of them.
Wait, would it be wrong?
It would not be wrong if you used the other ones.
If you wrote 2.45 and then negative 2.45
Because negative 2.45 is the same coterminal angle as 3.84, when you add 2k pi, they include each other. Sorry, say that again, Tane?
Like, it's in the general solution or including 5.16?
Yeah. And the reason, like if we go back to our notes when we first wrote out the general solution, okay? We wrote out the following. This might be a little bit shorter version of what we wrote out. Right? For the general solution, we wrote out solve first between 0 and 2 pi. And that's what I did before I x things out. That was my solution between 0 and 2 pi. And then add 2k pi to all of them. Part of the reason that I like doing that is if your original equation, you know how this one was from negative pi to pi? What happens if they said, no, we want your domain from 0 to pi? Then you would ignore this red part, right? It would just be the green part. And then this answer in quadrant 3 and that answer in quadrant 4 would just disappear. But then if you used the general solution and used those, you would get your general solution wrong because you would miss some answers. So for our general solution, if we solve between 0 and 2 pi, we get all of our angles in one time around. And then adding 2k pi to those will give all of the coterminal angles with those. Excellent.